We're starting to get people trickle in as part of top of hour. If you'd like to test your microphone, please do so. We'll get started in about 2 minutes. Hello, everyone. Thank you for joining our interim. It is showing 2 minutes after the hour at my clock, so we're going to go ahead and get started. Thank you for attending. This interim is very specifically targeted towards BGP next tops and link bandwidth. And again, the goal here is quick reminders of the presentations that we have going on and the different proposals that are going out. And the goal is to get some discussion about what we want to do about some of these things where there's a little bit of contention. We've had a lot of good feedback on these documents over the last couple of IETFs. As we've displayed while we're waiting, please pay attention to our note well, especially the IPR considerations. Everyone here is bound by these. In terms of our agenda, it'll be going slightly off of what the original agenda slides were. We'll be beginning with generic metric, moving into entry label, the next top capabilities. And from there, we'll move to multi-next top. And then after that, we'll move on to link bandwidth. The link bandwidth portion of the presentation will probably be a lot shorter than expected. We did not have any positive presentation sets offered by the people for the best documents. G, if you have a presentation for the link bandwidth extensions, I had not seen it previously uploaded. Maybe you've done it last second. And similarly, we've had no submission for the draft SHU IDR affair. So in terms of BGP next tops, what we're seeing across BGP and some of the motivation for us to have an interim meeting to discuss these things is we're starting to see that BGP next tops are themselves getting distinct properties attached to them, somewhat distinct from having the properties attached to the routes and being carried on a across the internet type basis, or VPNs as well. We did have as an example, AIGP was intended to be sort of a similar mechanism, and it picked up some semantics that were partially bound to the routes, partially bound to next top behaviors. And it was a initial start for us to talk about some of the incremental deployment and scoping issues we had. As an example, this served as an input for the attribute escape document. We're also seeing things like tunnel encapsulation attribute was being used to augment, things that are next hop scoped, especially for, carrying tunnels and attributes of the tunnels themselves. And we've seen other features, like CTA and CAR, that have headed further down that direction. One of the reasons why the scoping issues are sort of interesting is that they're effectively synonymous with security issues and are one of the things that we want to consider in terms of their properties. So our goal for this presentation is to talk about the different security properties and also the things that can be bound to the next tops themselves. And as we continue moving on, we're starting to look at some futures for BGP itself. So this is a good discussion topic there. For link bandwidth in some flavor has been deployed for a number of years. And the problem that we have is that they do not properly interop. And the primary points of difference in the implementations that cause the interop issues are, in terms of the scoping for the link bandwidth, transitive, non-transitive extended communities. And part of what we're looking for in the upcoming presentation on that is discussing the interop issues themselves, and also some of the use cases that are motivating this discussion to actually move to resolution after so long. Our long-term goal is we'd like to have a single protocol specification covering these things, and we're going to expect that we're going to have appropriate use case documents for each of these things over the long life as well. One aside is that part of the conversation here covers some ambiguity inside of the base BGP extended communities document itself regarding transitivity. The procedure that's actually written in 4360 says that if a route has non-transitivity extended community, then before advertising across a AS boundary, the community should be removed. Now, the use case is really clear if a router is receiving and otherwise would be propagating the route, and it's non-transitive. You'd want to basically stop there. The question becomes, is it possible to intentionally attach a brand new non-transitive one and effectively, as I like to call it, throw it across the wall of an AS session so that the adjacent AS can actually do this? The use cases that we're seeing, especially across the best documents, suggest that this is definitely a necessary thing. And we've seen other use cases as well in my employer. We're likely to need to do a small 4360 BIS to clarify this. So please pay attention to the mailing list for stuff on this topic. Before we get moving, is there any quick agenda bashing? Okay. In that case, let us move to our first presentation, which will be on the generic metric. And Srihari, did you want to drive the slides?
Yes, I will, or you can do that as well. Let's see. Can you hear me, Jeff?
I'm able to hear you. Just request click control the slides and we'll delegate it to you.
All right, please do that, then I'll move.
I believe you have to ask for it.
All right, ask slides.
There you go.
All right, okay. All right, this is an update as what Jeff and IDR chairs have requested for this interim. Is an incremental update, but more so covering the general solution, what the generic metric extensions for BGP that was presented in the last IEDR session, and something more in the context of what Jeff talked about the dependency of the next hop and what's the best carrier that we are recommending. And my name is Srihari Sangli. I am presenting this on behalf of my co-authors listed in this page. And this has been accepted as the workgroup document. So what you see here is the same document that was presented in the last session, just that it's a workgroup adopted document name. All right. So I'm going to cover these three aspects. I'm going to cover the recap of this exact problem statement and the solution, touch upon the relevance of this discussion with respect to the next hop, and I look for any comments you guys may have. All right. The problem is we have common administration with a number of different AS numbers, and they are connected such that operator would want to do end-to-end intent-based path and be able to make decisions, route traffic accordingly. The metrics that we're talking about can be any of IGP default, delay, bandwidth, or any other future administratively defined metric types. And we already have mechanism, AIGP 7311 talks about it, which defines only the IGP default. And the way it has been structured, we need to have another vehicle to carry any new extensions, specifically the generic metric extensions as defined in alignment with the IGP. What we need to do is find a different vehicle than AIGP, given the different interpretations of 7311 that's deployed today, and ability to identify any router that does not understand the new extensions or the new metric, and thereby making the path discontinuous. So both of these problems lead us to find a different carrier, an attribute carrier for this generic metric. And we have seen IGP define protocol, the metric types. So we would like to have a consistent metric type carried in the BGP as well. Oops. All right. The next set of slides just talk about the solution that is proposed in this document. We are recommending the next hop capability attribute as the carrier, NHC. It's optional and intransitive as defined in the draft IETF IDR entropy label. It does a fine next hop levels scoping so that we can leverage. So the accumulated traffic, accumulated metric, like I said in the previous slide, it matches with the IGP protocol type, and we have this structure as defined in the right side with the metric type and the flags, with some definitions for discontinuity, normalization of the metric as it happens. One of the things that we have seen, heard from the customers is one would want to have intent defined using one or more metric types, but it's quite possible that originator router may send more than one metric type on with it to be able to identify intent. So that's the draft clarifies that a router can originate more than one metric type, and that gets accumulated. And the next set of procedures that I talk about here is what does a non-originator router do? Non-originator router will have to look through each of the A metric. Unlike the previous one, where as defined in the next hop capabilities, you have to reformat all the capabilities. What we are asking here is you have to retain the received A metric and add the local internal intra-domain cost to it, and then propagate it forward. That's how you that's how you get the accumulation, and you normalize if the local domains metric type does not match with the metric type that's requested by the originator, setting the appropriate flags accordingly. And the D flag, specifically the discontinuity, if a router does not understand the metric type, then the D bit is set, which is used in the finding the discontinuity. Talking about discontinuity, there are three types of discontinuity as we have seen. One, type A, type B, type C as defined here. Type A, the router does not understand the NHC at all. Or the type B is NHC supported, but it does not support the new extensions as defined in this document, the accumulated metric. And the type C, it does support accumulated metric, but then it might not understand the new metric that the operator want to introduce down the line after the router has been upgraded to support both NHC and the base specifications of this A metric. So given the NHC, which gives the next hop level scoping, the type A and the type B are handled by the NHC procedures. So we can find out that the path is discontinuous and then take appropriate action, or leave it to the operator to take respective action. And the type C is identified by the A metric procedures as defined in this document. All right. With respect to best path computation, some of the things that the document mentions is it's quite possible that we have existing deployment of AIGP carrying the IGP default, and the generic metric, the accumulated metric carrying the IGP default. It is comparable. That's one aspect. And if there are more than one metric types, to break the tie, we are recommending the lower metric type to win. But then we also recommend the implementations to provide a local policy to be able to override the basic preferences. Some of the deployment considerations, NHC draft does provide guidance as to, even though it is transitive, the border of the common administration domain where you do not want, beyond which you do not want this capability or any of the attributes to leak. You have to have necessary precautions to filter it out before you send it out. In case it gets leaks out, the receiving router can also provide manual filtering or some through a policy. But in case even that is missed, it gets filtered by the first router which understands the NHC, or the first router that understands the A metric. So in any of these conditions, the actual accumulated metric will not be used. So therefore, we have that protection of inadvertent use. And then if the ingress router, in the general case where you do find a path carrying the NHC with the generic metric information with discontinuity bit set, meaning some router along the path does not understand and has not accumulated the metric accordingly or correctly, the operator can provide preferences through the policy, like either discard the path or put it a low preference, or use it for the tiebreaker as the operator can wish. And one of the guidance that we've seen both in NHC as well as in the 7311 document, and same thing that we are also recommending in this, is it would be better to have all the routers in the domain to use a metric in the best path computation, so that you get the consistent routing, unless we are using some sort of a tunneling and the operator knows that there won't be any wrong routing before the router from the ingress, before the traffic goes from the ingress router to the exit point. Okay, so relevant, those are the section that just covers the recap of all the solution that has been captured in the document. For this discussion, I've got a couple slides, and I'm open for any questions or comments people may have. Some of the thoughts about the generic metric extensions and the dependency on the next hop or the router that is modifying the next hop. First of all, we want generic metric information to be accumulated along the path, and as the route traverse, we want every router to add the cost, the intra-domain cost to it, and therefore the ingress router gets the cumulative metric. And that means only those routers that are modifying the next hop need to update the generic metric. And those routers that do not modify the next hop, they are expected only to propagate. That's one. And we need this accumulation, as we've talked about in the first slide, is because the operator wants to have a service intent end-to-end path established, and maybe select the path based on the lower metric or the optimal metric there. One of the key things is in the 7311, when the AIGP was introduced, it was introduced with the notion that I have the entire complete control of my domain. Even though it spans across multiple ASs, it is still my common administration domain. I know which router is upgraded or not upgraded, and it has taken almost like a decade now to see where we are from 7311 days, that we see AIGP is deployed pervasive. But then back then, the RRs were pure RRs. Most of the deployments had pure RRs, which means they did not modify the next hop. Whereas today, we see a lot of deployments with inline RRs and RRs modifying the next hop. So anything that require the router to, that modifies the next hop to add additional functionality means the RR needs to be upgraded. If RR is doing next hop manipulation, we don't have any other choice. But if RR is not modifying the next hop, then we do not want the RR to be upgraded. So minimal upgrade in the network is most desirable. And then it's not that every router will be upgraded at the same time. So discontinuity is going to be a reality. So we need to be able to handle the discontinuity in route accumulation and then acted upon it. Otherwise, it will lead to suboptimal routing, where we will prefer a path with a lower cost, even though it has not been accumulated correctly. Okay, so we are preferring next hop capability because of the fact that we have the NHC has the built-in next hop scoping in it. and an attribute is transitive, but at the same time the NHC document provides enough guidance and policy enforcement at the boundary, right? And it is simple, extensible to carry information related to the next hop. So that makes NHC more preferable from our perspective. Whereas MNH, the multi-next hop attribute, is information that is carrying for all next hop, for all the next hops, any attribute, any information related to next hop is going to be included within it. But as of now it is defined as non-transitive. That means the propagation will only happen if every router along the path does understand whether they need to modify the next hop or not. They still need to be upgraded, which goes back to the 7311 days where EIGP was defined as non-transitive and it required every router to be upgraded. So in the case of RR, if RR is inline RR, which modifies the next hop, then we have no other choice of upgrading it anyway. But in case there are RRs which do not modify next hop, using MNH as a carrier will force that to be upgraded, and something that we have heard from operators that we do not want RRs to be upgraded. It creates a lot of havoc in the network and operational issues, as we understand, right? So the recommendation from our perspective is, if there is a single path or a multiple path advertisements for a prefix, it must use NHC for accumulated generic metric to be propagated across the domain. And in case when we have MNH evolve and as it carries all the related next hop related information along with it, we would want the MNH to carry similar encoding. So coding and implementation will be a lot more easier to encode the generic metric. Okay, that's all I had. Any questions or comments?
Hey, Sherry, I have a question.
Sure, Kaliraj, go ahead.
On slide 3, you had mentioned that bandwidth inside the IGP metric TLV can also be carried um, in the A metric.
Yes.
So when that happens, like how does it correlate with the link bandwidth? That's also in the same update.
So this is the IGP registry as it defines today. It defines these metric types, right? So which basically means that we are talking about a router, the egress router, advertising the cumulative bandwidth throughout the entire administration domain, not just the DMZ links, but also the intra-domain bandwidth cost, all to be accumulated, right? So if there's a link bandwidth scenarios, as we understand, as we see, is more for DMZ links or intra-AS links, right? So this, if I understand it right, Kali, it will be complementary, right?
I think it's the same. Link bandwidth also have the same meaning, basically just bandwidth towards the next hop. So you may need to specify which one is like overrides.
But this will be will the link bandwidth be intra-domain?
Sorry?
With the link bandwidth community can be advertised over IBGP and EBGP, that I understand.
Yes,
But
yes, yes.
is the link bandwidth of the link that you advertise, will that be of a intra-domain link between two IBGP routers? No, right?
So I think
It is for EBGP.
so the way link bandwidth carries the bandwidth it's just the bandwidth towards the next hop. That next hop could be just behind a link or it could be behind a tunnel, anything. So yeah, I think it's the same semantic, same meaning.
Okay, so then maybe it makes sense to clarify this. I'll take that input and then clarify this. Yeah. The motivation for including bandwidth here is to make it aligned with the IGP way of computing the cost. And IGPs today compute based on let's say they take 10 gig as base unit and then come up with the cost per link based on that calculation. That was the motivation for having the end-to-end cost accumulated through bandwidth as a basic metric.
And I think one of the other distinctions is that link bandwidth is being used for ECMP in terms of which legs get which portion of bandwidth for ECMP, and we'll be talking about that obviously later. Whereas this one, as best I remember from the proposal, is primarily about biasing things like route selection. Correct?
That is correct, Jeff. That's a good thing. Yeah, that's a good way of putting it. Yeah. Any other questions?
And we're seeing some good chat right now in the chat channel. This interim is here for discussion, so feel free to take your comments to chat or to the microphone. Okay, it seems that people are not looking to do that, and I suspect that more of this conversation will come out as part of the link bandwidth portion of the presentation. So thanks for giving us an update on the proposal, and we'll go ahead and move on to the next presentation, Shrari.
Thank you, Jeff.
Okay, next one is going to be on our next top know something, the name to be determined.
And apparently I don't actually know which thing to click to request control. Oh no, maybe I have it already. I do. All right, cool. Hey everybody. I was looking, when I took this deck to update, it turns out that I gave this exact same talk almost exactly a year ago. So here we are again. Same spec, mostly, different name. So as a really brief reminder of what we're talking about, actually Srihari teed it up pretty well already. We have this attribute called NHC, which is there to tell downstream routers what it is we can do, mostly in our forwarding plane, but I'm sure it will be abused for all kinds of things, which is great, because that's what we do in BGP. And as Srihari already covered, it's optional transitive, but we do our very best to make sure that if the end-to-end path doesn't actually support the represented feature, the transitivity doesn't come around and bite us. And of course, it's TLV based. We currently have a couple of uses. One is in the draft itself, entropy label support, and another one that we have a code point allocated for is a different working group draft, next top nodes. There are a couple of other pending ones that we haven't allocated code points for. One is the one I just talked about, and another one is IFIT, which are both also working group drafts. So things that changed in the last 5 revs are, one is in the most recent rev, now they're characteristics instead of capabilities. Why? Because no matter how many disclaimers we stuck in there saying these are really not the same as the capabilities that we have in RFC 5492, it turns out that's not the way the human brain works, and you can't just take words that mean one thing and make them mean something else and expect people to respond to that well, which, duh, I guess. So I think Bruno came up with making it be characteristics instead of capabilities. It's not a term that we've already overloaded, and it doesn't change the acronym. Yay. And there were 2 especially large and iterative reviews from Mak Chen and Ketan Talalakar, and others of you as well. And so we made a ton of editorial changes, added a section on aggregation rules, and finally allocated a code point. There's one open issue that I'm aware of, having to do with link local next hops. The draft already talks about what happens if you have a BGP next hop that contains both a link local part and a global part, and says, well, you can just compare the global part, and that's good enough. Apparently, some of you are putting in no global part and only a link local part, which is kind of funky fresh. And that potentially breaks a correctness assumption in the draft. And this will become clearer in the next slide when there's an example. And I believe that this is going to have to finish getting thrashed out, because this is something we're still thinking about. But I think if you don't support, if you consider it to be an error to receive a next hop that contains only a link local, this situation can never arise. But otherwise, don't go get your tea right now. So here's an example. So we've got a super simple peering topology here. And as with all examples, you could come up with different ones, but this is the one I chose. So we've got 3 ASs, 4 routers, and let's suppose that A and D support NHC, but the guys in the middle don't. So the way it's supposed to work is if A sends a route that's got an NHC on it, and then it goes through B, and then it goes through C because it's transitive. C does next hop self, as eBGP routers often do when sending the route to D. D gets the route, takes a look at the NHC, takes a look at the next hop it got, says these don't match, throws away the NHC, great. Okay, now let's suppose that A peers with B using only a link local, and C peers with D using only a link local. And just to make things worse, they have just happened to have chosen the same link local address, which, if they're using, what do you call them, EUI addresses, that's vanishingly small probability, but sometimes people configure their link local addresses, so could happen. Now what happens, the way the draft is written, is the same scenario. Route goes from A to B to C. C sets next hop to self, which happens to be the same address that A put into the NHC, and D has no way of detecting that this fault condition exists. Oops. So there's a proposed solution still under discussion. The idea is basically when you're doing this particular kind of grossness, sticking a TLV that further qualifies further identifies, I guess, the NHC using your BGP identifier and AS number. Well, AS numbers are supposed to be globally unique, and BGP identifiers are supposed to be globally unique within an ASN, so this thing really ought to be unique. And we hope that's true. So then you do the obvious, is when you get one of these things that has just a link local in it, you compare the other stuff to, and if it doesn't compare right, then it's not a match, and if that thing is missing, it's also not a match because you can't tell. One thing to notice about this is that since link locals are supposed to be link local, the only thing you should need to worry about is, did this NHC come from my direct neighbor? Because the NHC has an address in it that should only have come from a direct neighbor. So that means I should be able to just compare the BGP identifier and AS number that I see in the NHC with the BGP identifier and AS number of the direct neighbor, which I've gotten out of the open. And hopefully we'll get some text nailed down on that and publish it as a version 16, and then people can take a harder look at it and see if they like it. One other thing to make the group available, group aware of is that I think we talked about this before. We have this sort of ad hoc registry in the back of the draft, i.e. we have the IANA section and it lists code points. Some of the code points are ones that we are using within the draft, like the ELCP3 code point. But since other drafts are starting to rely on this one, like the one that Srihari just presented, we need a way to get them code points. And at this point, we're doing what other working groups in the same situation have done, and just saying, well, okay, if you need a code point, ask the editors of this draft, and we'll give you one unless there's a problem with it. So there's a couple outstanding right now. We've been copying the chairs and all the requests, and it's working fine so far. If you have any need for a code point, now you know where to go to get one. And keep in mind that the part of why this feels okay to me is that the proposed allocation policy is first come, first served. So there's not a big expectation of working group oversight of what code points get allocated. So equally, the editors are not trying to apply detailed oversight. It's just, basically, if you ask me for a code point, I will give you one. So yeah, we've had one implementation sitting around for quite a long time. As we just talked about, we have a solution for the registry. It's not ideal. It would really be nicer to have IANA do the work. So, just from that point of view, it would be great to push this over the finish line. Just before getting on this call, I heard there may be a second implementation in the works. I'm really hoping that we can get it reported so that we can send this for publication. I guess it's good that it got held up as long as it did, just so that we could identify this link local thing and roll it into the base spec instead of having to do it as a follow-on spec. But really, I'd like to get this finished. Thank you. Any questions or comments? And I do see the stuff in the chat, but I haven't been trying to read it as I talk, so I'll go back and look at that.
Yeah, just to give my point from the chat. So link local peering may not necessarily carry a link local next stop, although that is one of the most common of the use cases. So one of your interesting bits here is that the information that we're using for discontinuity might actually be, just the usual thing via a strange way of carrying it.
I'm not 100% sure I followed the point, but we can follow up later. But I will say that, if you have a link local peering and it doesn't use a link local next hop, then we already don't have a problem because
exactly.
So yeah, it's all good. So we're trying to fix, sort of a very edge case, but it's always nicer to have a spec that is as close as possible to technically correct than one that you have to say, well, this is a bug, but it doesn't really matter.
So in the two chair follow-ons, Sue and I had a conversation with IANA at last IETF about these types of situations, and it looks like IANA might actually be making some level of progress towards early registry creation for these types of scenarios. As one item. The second item worth mentioning, an option that we have is, you could certainly check your draft into the IDR GitHub, and the issue tracker there can help us, do the coordination that's necessary for doing the registries. And that way, we're not using everybody can edit it wiki to do that work.
Right. Right now we're not using a wiki or even GitHub. We're just using old-fashioned email, which, if we had a high volume of requests, I think that would not be great. But given that it's a low volume, it seems okay to me. If there's a strong desire to change to using GitHub for that purpose, that's fine, of course. But right now I don't intend to prioritize it in that, like I said, I'm really hoping to just push it over the finish line, and then we won't have this problem. But again, you can ping me offline if you think I should change that. Other comments or questions? Otherwise, keep your eyes open for version 16 because we will definitely want some eyes on whatever the proposed solution ends up being. And speaking obviously only as an author, but if we do put in that modification, if I were the chairs, I would last call at least, and probably at most also, that the new functionality that we'll propose. So we'll want some working group eyes then.
Right, and aside from the link local thing, I think we have enough deployment experience to know that this seems to be working out fairly well. So a last call seems perfectly reasonable.
Right. Okay, looks like we're done. Thanks, everybody.
Thank you, John. Sue, please go ahead. Sue, you're looking to speak? Okay, well, in that case, we'll move on to multi-next-top.
Hello, everybody. So maybe I can ask for the slides. Hi, everyone. I'm going to present BGPM, multi-next hop attribute, the status of it. So the agenda is to have a quick recap of the background and problem statement and the multi-next hop attribute itself, and go over the changes to the draft since the last IDR interim, which includes clarification of interaction of forwarding information that is carried in the MNH as well as in the rest of the update, and some error handling enhancements using a new bit called mbit, and continuity detection enhancements using the bits called C and E bits, and accumulated metric has been added as another attribute in the forwarding arguments section, and we'll discuss the next steps. So as a background, like what we already discussed in the previous sessions, how we carry next hops in BGP. So basically, what is a next hop? A next hop is an instruction on how to forward a payload to entities specified in the BGP NLRI. And what comprises that instruction is broadly the endpoint identifier, basically where to forward to, what encap to use, and what are the constraints, like whether it's single hop, multi-hop, or what color to use for the path, and the endpoint properties like bandwidth, AIGP, and other good things that we are talking about. And how do we carry this in BGP today? Is like we use multiple attributes and multiple extended communities and the portion of the BGP NLRI. So they are totally about 6+ attributes and 6+ external communities that we use to carry all this information. And using all this, we are able to carry like 1 unit of forwarding information on a route. And because it is scattered across the BGP update, scope checking and error detection may not be foolproof. So what are the problems in the current way of expressing next hops in BGP? So the information is not scoped in one place, and there's inability to advertise more than 1 next hops in a route, except for add path, but add path is not able to express a relationship between the different next hops, active, backup, UCMP, and in some scenarios, add path becomes scaling heavy. And if you want to extend carrying the forwarding information to newer endpoint types and encapsulation types, that's like a big change. And then we are not able to, let's say, like signal the encapsulation information uniformly across the families. For example, carrying a label for SAFI1 routes or flow spec routes. If some scenario requires it, we won't be able to do it today. And also in some cases, we want to carry multiple label stacks, or basically a different information for the primary path versus the repair path. And we are not able to do that today. And there have been some attributes proposed to do that. So here, MNH, in addition to do everything else, it's also able to do the carrying the additional label stack. So these are the problems that are solved by the MNH. So what does MNH look like? So as a unit of the MNH is a forwarding instruction, which has the forwarding action and the forwarding arguments. And the MNH attribute just contains the primary path and the repair path. And the primary path has a set of forwarding instructions ordered, and the repair path has similarly set of forwarding instructions. So that's what an MNH looks like. So the changes to the drafts since the post IDR. So first thing is post adoption, the draft name was changed. And then whatever review comments we have been receiving during the adoption. So I've been incorporating those review comments. There's a GitHub repo created for MNH where you can see these issues and changes that are not hit IETF yet, but they are being accumulated in the IDR, in the GitHub. And also, if you want to go through the overview of the list of comments during adoption call, the previous interim, we discussed those. And there has been a little bit of reorganization of the draft. So basically, section 4 has base encoding and protocol procedures, and section 5 has the specific TLVs that have been defined in this document. In the next slide, we will see like what's the difference between those. And based on the input from the adoption call, I have removed the label descriptor TLV from this document, and we can take it up as a separate document in the future. And then these are the additions. Basically, these we talked about in the previous slide. So to save time, I'll just move to the next slide. So here we have a UML representation of the MNH, basically what it looks like. So whatever is in the black boxes, they are like the basic skeleton or the framework of MNH. You just have the MNH attribute. It has a primary and a repair path, which has a next up forwarding information, which consists of n forwarding instructions. And the forwarding instruction has a forwarding action and a set of arguments. And here you can see that the colored boxes, they are like instantiation of different types of TLVs. For example, we have a primary path TLV and the repair path TLV, and then different types of forwarding actions we have, like forward, push, and then different type of forwarding arguments. Like some of them are like endpoint constraints, encap info, and attributes. So I alluded to the reorganization of the draft. So section 4 describes the skeleton framework, which are the black boxes. And section 5, it defined all the color boxes, which are basically the entities defined in this draft. And in future, you may have other drafts which are defining these colored boxes. So as we see, what MNH is trying to do is it's like trying to scope information that's already carried elsewhere in the BGP update into a one scoped attribute. So it may naturally happen that information is carried in multiple places, 2 places at least, one inside the MNH, one in rest of the BGP update. So how do we correlate which one we should use when we are constructing the forwarding using MNH? So the basic rule is that the forwarding information that's carried outside the MNH, it's applicable to the next hop that we carry with the route. That's a single next hop. That's an attribute code 3 or 14. And so all of that together forms one unit of forwarding information. And any forwarding info that is carried inside the MNH, it's more specific, and it applies to the associated endpoint that is carried in the NFI. So the information carried inside the MNH, it overrides the information carried outside the MNH in the same update message. The only exception to this is the MPLS labels that are carried in the 8277 NLRI. So they will be imposed as an inner label, and any encap carried in the MNH will be imposed as the outer encap. So that is the general rule of how do we sort out differences, or what is the interaction between these two scopes. And MNH introduces error handling using a bit called mbit, which is present in each layer, each level. And well, it tells whether the element is mandatory. For example, if you have a forwarding instruction, the forwarding instruction may have like some attributes, set of arguments. Now, a forwarding instruction may not be able to execute completely without a certain argument. So then we can set the argument to mandatory. And it may be that this whole MNH instruction is not complete without a forwarding instruction being able to be executed properly. So in that case, the forwarding instruction is mandatory. So mbit says whether that specific element is mandatory or not. And if it is 0, then any errors during processing of that element is ignored, and we continue processing. And if it is 1, then any errors that are encountered are percolated up the layer. For example, if we are not able to understand a forwarding argument, then and the mbit is 1, then we say the forwarding instruction is invalid. And then if the forwarding instruction was mandatory, then we say the error percolated up to the next forwarding info, which percolates up to the MNS TLV. And based on the TLV, let's say if it was a backup path, and backup path is an optional thing in that particular deployment, then we can continue processing. But if it is required, then we say the MNH attribute itself is not usable. And the MNH attribute also has the same mbit, which says whether the route should be kept as hidden with retest withdrawal semantic, or the route can be processed further by ignoring the MNH attribute drop. So in any of these circumstances, we don't bounce a session or take any other harsh measures like that, because we are able to semantically parse the MNH properly. We're just taking decisions on how to handle any errors in a simple and hierarchical manner. And one thing to note is, like, because it's a new attribute, and in any deployment, we may want to see how it fares, whether there are any errors before we deploy it. So we could kind of do a dry run by setting the mbit to 0 first on the MNH attribute level, so that we can see after we send the MNH attribute whether we see any errors. And if we don't, then we can resend the attribute with the mbit of 1, which deploys it, and then it makes it mandatory for the functionality. So for continuity detection, there have been 2 bits added, C and E bits, and these are only in the forwarding arguments TLV, not in the other TLVs. So in general, forwarding arguments are also, like in the MNH, they're consumed on the receiving hop, because MNH is by nature, it consumed on the receiving hop, and it's not propagated further as it is if the next hop was modified. So any new MNHs that may be created, it may create the forwarding arguments fresh, and some of those may accumulate values from the received forwarding arguments. So CBIT is a way to request that kind of contiguity or cumulative nature. So it is set to 1 by the node that attaches the forwarding argument to request the future nodes which are doing next hop self to accumulate or make that value contiguous. So the intermediate nodes, when they receive the forwarding argument with CBIT set, and if they are doing next hop self, they accumulate the value and re-advertise the MNH. And each attribute, it specifies how the contiguity is preserved. For example, if we have something like AIGP cost, we may want to add it to provide the end-to-end AIGP cost. But if it is something like a bandwidth, then we want a minimum function. So the contiguity function is specified by each attribute type. And CBIT just says that the property that the ingress is seeing is not property only until the another intermediate hop, is a property until the hop that actually added the attribute. So by default, forwarding arguments are not cumulative, and each forwarding argument specifies whether CBIT is set. and what the contiguity function is. And there is an EBIT, which is which signifies that this attribute was attached by the egress node. It is maintained alongside CBIT. So basically, it's not just that the attribute accumulates information until the node that attaches the attribute, but I want to know whether the node that attached the attribute was an egress. So this bit is set to 1 if the cumulative argument is being added to a route when its AS path is empty. So that's how we can ensure that it is added by either the egress P or the ASBR in the egress domain. So using both these bits, the ingress can deterministically know whether the forwarding argument is like contiguous and until the egress. So this is just yeah. So accumulated metric, which is added, it sets the CBIT to 1, and it uses the EBIT. And any other forwarding arguments in future can use continuity detection. For example, bandwidth can do that with a new bandwidth function. And if, for example, we want that, okay, the path, let's say if we want to say that we want the path to be a single hop all the way, we don't want to use any resolution, direct hops, then we can set the CBIT on the proximity to say that this whole path should be single hop. Or if you want to say this for things like transport class constraint, where you want to say you want to take the same color path on every hop. So there also we can just set the CBIT. So yeah, so the way accumulated metric is been added in this section. So it allows a subset of the IGP metric type registry to be carried in the MNH. It includes the IGP cost and the link delay. The IGP cost is the equivalent of accumulated IGP cost, AIGP, and the link delay is also accumulated. It does not include the T metric and the bandwidth, and this is pertaining to the confusion I was having earlier on the chat. There are questions to Srihari. So because the bandwidth is carried in link bandwidth as well as inside the IGP metric type, so I found it a little bit counterintuitive. So, and I also felt that everything that may get added into IGP metric type tomorrow may not have procedures specified at the BGP layer. How do we handle it if we receive that forwarding argument in the MNH? So that is why I just took a subset of the IGP metric type and specified as applicable in the MNH. And that is one of the reasons why MNH did not use the same encoding as A metric, because that's what I tried to do first. That's in the NHC A metric data. So this is one of the points. And the other point is like the continuity detection in the A metric is done at the A metric layer, not at the NHC layer. Whereas in MNH, it is done at the MNH layer in the framework in the base machinery, so that any attribute can take the benefit of it. So even if we bring in the A metric data into the MNH as is, the D bit in the A metric will not be needed because that functionality is provided at the MNH layer. And another thing I noticed that the A metric data is not a TLV format. In MNH, all the arguments, we try to keep it in the TLV format. So these were the reasons why MNH did not use the same encoding. We can discuss this further offline. And another discussion point was relating to the IGP metric type registry diverging from that. So the reasons I diverged from that is what I specified now. And I just received a suggestion to say that we can create a separate registry instead of confusing, taking a subset of registry. I kind of agree with that. So I'm pondering on whether these accumulated metric can be just renamed IGP cost and brought it as a top layer forwarding argument in MNH instead of a nested accumulated metric and then IGP cost, so that anything else like latency can be also added as a separate forwarding argument, so that it keeps things simple. And there's like one registry which clearly specifies what MNH allows, and it is separate from IGP metric type, so we don't have the creep in of types that we don't know how to handle. So this is just an example of how the continuity detection works. So here we just have a network with 3 ASs, and these are just all the nodes are doing next up self. And the nodes in blue, they all understand MNH, and they understand the AIGP carried inside it. The node that is like a full orange or red, that does not understand MNH, and the node that is like red and blue both shaded, that understands MNH but does not understand AIGP. And you see a red link. So this link is where the link delay is not known. We're not able to detect it. So basically here, any routes that are originated from PE21 and PE22, they will be propagated across next hop self and these places. And this guy will set the MNH with the AIGP with the C bit and E bit set. And it will get pruned here because MNH is optional non-transitive, so it will not reach. So PE2 and PE24 will get pruned. So PE24 will propagate the MNH if it is provisioned to do so again, but it will not include the AIGP because it does not understand AIGP. So eventually we get two paths end to end where we have the latency known. So this node, though it understands both MNH and AIGP, but it is not able to figure out the latency, and that will mean that it will not propagate that that argument further. So eventually, the ingress PE1 is able to discover two possible paths to PE21 and PE22 with the known end-to-end latency, which it can work on. So this is just a protocol machinery of how the contiguity detection works. So I was also asked to give an example config of how the MNH may look like when people provision it. And this is how it may look like. So this is just kind of an artist rendering of how life looks like on Europa. So it's like not a reality yet, especially the policy config part. So the idea is that we already have the state on the route that we want to send as multiple next hops, multipath or whatever. And we just say on a per family level or per neighbor level, we enable use of MNH, and then we can have a knob to say dry run, which controls the M bit. And similarly, and on the policy level, we can have like export policy to add MNH and specific values in it. Like if you want to send explicit null in the MNH for INET6 unicast routes. And this is like in the ingress, based on some properties of the MNH, we want to give it better preference, something like that. So it's just an example config of how config may look like when MNH is implemented. And this is just another use case that was added in the draft, which is similar to the previous use cases that we have talked about, where we talked about label oscillation between the two PEs, where it's like a multi-homed L3 VPN PE with the PEs using per next hop label allocation. And recently, I encountered another customer case where basically both the PEs were using VRF table label. And so that avoids the oscillation. But let's say if CE1 goes down, then it will obviously have forwarding loop between PE1 PE2 until the global convergence completes, because IP lookup at PE1 will point towards PE2, the IP lookup on the backup traffic, the repair traffic. So even in this case, we can use MNH to make sure that the backup path does not turn back. So basically the primary path traffic will do an IP lookup, and the backup path, whatever label it inserts, it will just go to just a CE. It will not do looping back to the core. So this avoids the forwarding loop. So just an additional use case that was added to the draft. So the next steps are like we are working on the implementation and some customers are willing to try out for some of the use cases that they have. And though the framework contains a comprehensive model of how to solve things for the future, but we want to start short and iterate. So that is how we want to go about implementing it and seeing how it goes and adjust the draft accordingly. So hopefully before the next next time when we are meeting for the discussing MNH, hopefully we have something to show you working. So that's all I had. If you have any questions, I can take now.
Srihari, you have the cue.
Yeah, Kali, I was just thinking through. I might not have gotten the entire concept correctly, but question is, go back to which is your slide 14.
Yeah.
Let's say you introduce a new new metric, and the assumption is every router, there is no all the routers are blue, which everybody understands the base MNH and base A-metric machinery, and a new metric type is introduced that is not understood by certain routers. What happens then? So the C bit is enabled. C bit is as the originator. He wants to have the accumulation done. So C bit is always set to 1, and intermediate router that does not understand the new metric. What is the behavior? Can you please?
Yeah, so that is the example of this node, which understands MNH but does not understand the new metric or new forwarding argument. So because he doesn't understand the forwarding argument, it will not be propagated. So there even yeah.
Okay, you'll not propagate. Okay, that's fine. So you'll not propagate, and therefore the ingress router will figure out that there is no
Right.
metric,
You won't even
and
see
therefore
that.
not usable. Okay, so you're using the base NHC. Okay, fine, got it.
Yeah. So here, this is a good question, and another interjection to basically the things that we discussed in the previous presentation about MNH, why it is non-transitive. So it's like we have to err on the side of either keeping upgrade happy for a short period, or the attribute escape problem and other continuity detection things. They are like complicated problems, and they'll be living for longer. So here MNH is erring on the side of a little more hardship in the short term for upgrading routers, only the RR actually, and basically makes it easier to do for the attribute escape problem and continuity detection by keeping it non-transitive. It's like more tightly scoped. So that's like the broader theme you would see with MNH, that we are trying to tightly scope everything so that by default things don't leak anywhere, and you have to like explicitly let it go.
Yep. Okay. Got it. Thanks.
Thank you.
Ketan?
Hi, Ketan Dalaulika, Cisco. I hope you can hear me.
Yes, Ketan.
Okay. Thanks, Kaliraj, for the update. I think there were two main motivations for the draft or for the proposal. One was to make it possible to send multiple next hops, so multiple primary next hops or in one single update. Is that correct? So kind of replacement for add paths.
Yeah. So they're like, so I have taken your input, Ketan, if you're talking about that. Basically, even in the introduction section, I have said that it does two things, where MNH consolidates all forwarding information into one attribute, and it allows to carry multiple units of that kind of forwarding information. So that's like both at the primary path, repair path level, and even the primary path, you can have multiple legs.
So is it so it's kind of like a replacement for our add paths.
Yeah, I wouldn't say it's a replacement for add path. I would say it works in conjunction to it, complementary, because that's how it is defined in the draft also. It's not a full replacement because it does not advertise all the routes and all the attributes along with all the other routes. So it is advertising more information on a single route. That's what it's doing.
Oh, okay. I will go through the update and I'll get back on this one.
Okay.
The other part is really putting everything or all information related to a next hop together in one attribute. Whether it is so, is that only for things? I'm assuming that's only for interest of those that are changing the next hops, or is that correct?
I couldn't get that. Are you asking why are we
So
trying to scope?
so scoping is one part, but is it only something that needs to be taken care of by routers that are changing the next hops or updating the next hops, or
That's
by all routers?
no, only the guys who are updating the next hop. So basically, at the RR, which is, for example, not changing the MNH, whatever is received in MNH is reflected as it is.
Sure, but here the RR would still use that information for its best path, correct? In
It
that
could,
sense.
yeah, it could, yes.
Okay. So what's the goal or motivation here? Do we want to bring in everything that is specific or a next hop characteristics into this new one single attribute?
Yeah. So what is the motivation of having it all scoped properly in one attribute is so that error handling is easier and we are able to correlate different things to a certain endpoint. For example, if you want to even create a new type of endpoint tomorrow or a new type of encap, it's like a small change, a new type in inside MNH instead of it being a new extend community or a new attribute and stuff like that. So extension in the future will become easier.
Yeah, thanks for clarifying. My question was that I understand that's a motivation. So,
Mhm.
but what it means is that we do no longer define any other attribute. We, as in the IDR working group,
Mhm.
doesn't do any other attribute, and everything goes as TLVs inside this one single attribute.
Only the things that are related to forwarding properties.
Okay, do you have an example in mind where something is characteristic of a next hop but
Yeah,
not related to forwarding?
yeah. For example, things that control path selection, for example, local preference and other kind of things, which are like they are things which are controlling the control plane decision process, but it is not eventually getting into the forwarding. So these are like all elements which can get into the forwarding, or it tells you something more about the endpoint that you're trying to reach. It's a forwarding information towards that endpoint.
Okay, but that is because today each path that is advertised in BGP or basically carries is considered as has its own local path, local preference and all. But here, I'm sorry. Here we are merging that notion of path. We are changing the notion of path by allowing multiple next hops to be advertised, right?
Yes, but the local preference will still be outside in the BGP at route level. Local preference will not go into MNH.
Okay, okay, okay. I'll review the latest update and I'll get back to the mailing list. Thanks, Karim.
Right. Yeah, and like Natko, like our list in the chat, it's also like there are some cases which need the ordering to be specified as a specific order. So MNH is able to do that. I've seen some people getting excited about that. Okay, thanks.
And as my follow-up specifically to what Ketan said, uh, one of the things that I think we'll want to make sure is called out very well, since we're starting to merge some of these use cases, is effectively when components inside of MNH are route selection impacting versus not. We gave examples of things like link bandwidths versus metrics in the prior discussion. What is impacting the actual route selection. Some of the properties that we're discussing maybe going in here could impact route selection or route sieving. Color is an example of that, versus just simply controlling once you've picked the route, how the forwarding actually happens. So that's one set of things. Overlapping some other discussion points I threw into the chat. So for slide 9, one of the things that suggest for the next iteration, you called out labels as a thing that is sort of special case, kept as separate behaviors that override stuff inside the MNH. BGP car optional LRI components are in that category as well. And primarily my comments for 10.11 and the follow-on of that. This is an example a little bit like we're seeing out of things like BGPLS and to some extent tunnel and caps attribute in some circumstances, where a lot of our work here is keeping the fact that we have a container that can contain functionality that is done elsewhere, and making sure that it's kept in harmony in terms of representing the code points when it's appropriate. We have that discussion for LS versus like the IGP code points is one example. And the second one is when we actually encode things inside of MNH that we try to use very similar formats on the wire. Okay, do we have other comments and questions? Okay. Thank you, Kalaraj. We'll be moving into our link bandwidth discussion, which is one of those attributes that can be encoded inside of multi-nextop. Now, that's one of the reasons we arranged to order in the sense that we did today. So we'll be working from this presentation as our primary discussion point. We will actually be touching on the other items that had been raised in the agenda. Briefly, I'll be displaying from web browser for some of these other points, to wrap things up. But I think most of our initial discussion will happen here. So Reshma, are you ready to go?
Yes, Tom. Yes, Jeff.
Okay, you have slide control.
All right. Thank you, Jeff. Hello, everyone. So we will be talking about the link bandwidth extended community. My name is Reshma Das. I work with Juniper. I will be presenting this on behalf of my co-authors. So briefly going through the agenda. So I had presented this in the last IDR, IETF 120. So we'll just recap why we are having the solution, what is the current landscape. Today I would like to spend more time on the solution, how this achieves the goals we have set, and what we are seeing currently in the field, and what are the next steps. Okay, so quick recap. We have an IDR draft that has been adopted in 2009, expired since 2018. So the IDR draft currently defines it, not currently, earlier defined it as non-transitive external community, which means that the type field is 040, 0x40, and it would not be advertised from one AS to another since it's non-transitive. So the current draft fails to talk about intra-AS scenarios. It doesn't talk about next up self unchanged. So a lot of scenarios are not documented well in the draft. So what is the problem? So there's a limited interop because some implementation has implemented it as transitive, which we have seen as deployed in field and custom uses it. And some have some implementation has implemented it as non-transitive, and so there is no interop between these solutions. So because of which the IDR chairs has requested to work on this. So because of this problem of transitivity, we see that currently there are many solutions that have many different drafts that have popped up, and they each address this in a different way. Whereas, to quote some example, which as the chair has said that they will be going through some of these drafts next, is the best one, which is an EVPN draft. They specify a new community, which is transitive in nature, and it uses a new format to carry link bandwidth. This draft, particularly in its Appendix A, states that this draft exists because there is no transitive nature of the current IDR adopted link bandwidth community. Another one is the IETF is the best eBGP DMZ link one. This also works over the currently adopted link bandwidth draft, but it introduces a knob at the enable level, which allows advertising as well as accepting the non-transitive link bandwidth community across an eBGP session. So this draft is particularly like works over some ambiguity over the RFC 4360, which does not address how whether we can originate over a inter AS link. So this is also some clarification that the base RFC needs. Draftly, which also this introduces a new extended community and a new format, which carries the link bandwidth value in a different in a 64-bit format. I'm sure they will talk about it. This draft recommends the link bandwidth community to be both transitive as well as non-transitive in nature. And then we have another draft which talks about a new path bandwidth, and this also introduces a new community. And here it does not mention, I fail to remember whether it mentions transitive or non-transitive, right? Then we have MNH, which Kali has already talked about, and it also has a link bandwidth attribute, but MNH is out of scope for our discussions. I think mainly these are the drafts that work on or over the current adopted link bandwidth. So what is a solution? Like, how are we going to carry and interop link bandwidth, transitive and non-transitive link bandwidth community? So what we have suggested is like the sender. Sender should be able to originate both transitive as well as non-transitive link bandwidth community. And this implementation should provide a configuration to set what is the transitivity type. As the current IDR draft, we say that we recommend that no more than one link bandwidth community shall be attached to the route. And a receiver must be able to receive both the transitive as well as non-transitive link bandwidth community. The receiver should not flap or treat the route as malformed based on the transitivity of the link bandwidth community. Now, conflict management. So let's say this is just to make sure that there is an error handling. Currently, the draft does not talk about any. So if more than one link bandwidth community is attached on the route, right, then we should prefer the lowest value of the link bandwidth community attached, irrespective of the transitivity type. If both the values are equal, then we should prefer the transitive link bandwidth community over the non-transitive. Implementation should provide knobs to change the preference either of 1 and 2. Re-advertisement with next itself is same as the procedures of sender. And it follows any extended community. Like if we are not changing any extended community at import or during export, then whatever is attached on the active route should be sent. Re-advertisement next up unchanged. It should be same, and we should not change anything on the link bandwidth community. So what is this solution trying to achieve? So we are trying to achieve interop with least bit of changes with the to the current adopted draft. Keep the changes simple. One of the assumptions that we say is that the receiver should be updated. To keep the procedure simple, we do not support an old receiver, but an old sender can of course talk to an old new receiver because of the knobs. We want the draft to cover all applicable cases. We need to talk about intra-AS, inter-AS, every case. We need to define proper error handling. And we have already published this current draft version. So we have revived and retained existing draft, which we think that solves most of the use cases the other drafts are talking about, which we can go in detail as we talk about the other drafts. So what we are seeing currently is that we have deployed, the deployments have both transitive and non-transitive versions that most of the vendors support. Juniper has implemented the sending and receiving of both transitive and non-transitive form of link bandwidth extended community. We see incremental support from other vendors to receive and send transitive and non-transitive versions of the community. We are talking to multiple vendors and so we are gaining support of this solution. And we have also talked with Google, and OpenConfig will also be adding support for both transitive and non-transitive link bandwidth community. So what are the next steps? We request the working group to review and discuss the solution. We request vendor participation in hackathon in the next IETF to show interop, standardize the solution, and as I spoke about, clarify the 4360 RFC about the inter AS case. Thank you. Any questions, or we can go through use cases if anyone wants to discuss. So.
Thanks, Reshma. That's a nice, concise version of where we're at. So minimally, I'm looking forward to the fact that we are making progress at resolving the interop issues. So this is a happy thing. One of the things I wanted to quickly throw out as a discussion point is that the Yang language, which IETF has been moving to for operations-related stuff, doesn't have a way to easily represent 32-bit floating point math, and that's causing some interesting modeling challenges. My recommendation is, if you are following this topic and also have interest in manageability, please take a look at work that's currently happening inside of OpenConfig and also inside the NetMod working group on this topic. And this will be interesting for you in Yangland. We have a nice queue started. Ketan, you're next.
Hi, Ketan, Cisco Systems. Thanks, Reshma, to you and your co-authors for taking up this work. My questions were actually on slide number 4. If you could please go to slide number 4. Yeah. I thought, so the draft number 2 that you're listed here, I thought that you meant, did you say that, did I hear correctly that this works on the draft number first? I thought you.
Draft number 2 you're talking about, this one?
Yes. Yeah.
No, it works over the current adopted, the link
So
bandwidth.
okay, thanks. So from what I see, this is actually seems like more of a let's say complementary draft to the IDR link bandwidth, which is informational in nature and discusses how to use it and things like that. So I think it would make sense that the use cases and other usage is documented perhaps in this draft, in the second draft here, and that the both are complementary and that they progress further.
We
I
agree.
wanted to know. Okay.
Yeah. These are more like capturing the use cases where, and this is currently an informational to the second one.
Okay.
Yeah.
But there is there isn't. I don't know if there have been discussions, but I didn't see anything that is conflicting or an issue between the draft number 2 here and the IDR link bandwidth. Is my understanding correct?
It is correct, but what we say is that currently it is like a knob to send the non-transitive link bandwidth extended community. Maybe if the users can support both transitive and non-transitive, yes, we still need a neighbor level knob to send that over the link inter AS link. But yeah, this is more like a use case capture. You're correct to say that there's no conflict between these two tracks. Yeah.
Okay.
But we would want the ambiguity on the RFC to be defined properly. So that's why I just wanted to highlight that also.
Yeah, I think both talk about it, and I think it it came up in a previous presentation also. That seems like a separate thing.
Correct.
Okay,
Yeah.
thank you. Now I have one more question, which is about the draft number 1. So the draft number 1 is not just about the transitivity part, but it also came up with a more I would say, more flexible and more versatile encoding mechanism for carrying link bandwidth. It so happens that it was defined for EVPN SAFI, but I'm sorry, but I don't see a reason why it could not be a more general or generic BGP. Uh, could be used for generically in BGP for other SAFIs as well. Could you share your thoughts, or if any discussion has happened on that lines?
So I had a discussion with our within our EVPN team, and from the feedback that I have received is that if there was a transitive nature of the link bandwidth community available, they could use that as what was the feedback that I had received. But this is something that yes, we should talk within the forum, and if anyone from Best can add more details to it, it would be great. But the feedback I have currently received, if a transitive nature of the current IDR link bandwidth was available, this was not required. But I'm more than
Okay.
welcome to more comments
So,
on that.
so maybe I'll repeat, the transitivity thing is just one part, but
Hmm.
it has a new format or encoding, which I think is also very helpful and can solve and address some of the other use cases. It's purely encoding, but I think it's a good encoding proposal that fits inside an existing, widely used extended community, as opposed to the proposal in draft number 3. But maybe I'll I'll hold that comment for that presentation.
Sure. Yeah.
Thank you. Thank you.
Thanks.
Okay.
Go
Thanks,
ahead, Krishna
Ashma. This
Swami.
is, yeah, I'm Krishna Swami from Cisco Systems. I think I had a similar comments what Ketan had. Just to add on top of it, right? So the first draft, it's been adopted in 2018, and there are already an implementation and deployment of this, the EVPN unequal load balance. Even though the draft is defined for the use case of an EVPN, but the attribute itself could be generic, and if needed, that could also be reviewed in the best. So I think we should definitely look at it, or maybe have meetings with the authors of this draft, and to conclude, and if there are any deficiencies that this draft has and that is being overcome by the new draft that you presented. So probably we should have this one meeting.
Yeah, I would say it is a bit disjoint because, as I said, one of the things we are really trying to solve is the interoperability of the current adopted IDR draft. Um, so that that's the is one of the biggest goal that we are trying to solve with the this particular presentation, this draft updation. Also, yes, I agree with you that we have to speak to the authors because from my reading in the Appendix A suggests that if there was a transitive and also discussions within, if there was a transitive version of the link bandwidth available, this new format wouldn't have been required. But saying that, I would also welcome, as I told, answered Ketan, that I welcome discussions so we can see if it adds and solves more use cases, and not if the transitive version was available, would that still hold up? Yes, that discussion should be opened and it should be discussed. I agree
Yeah.
with that.
Yeah, sure. It is just that, this has been there from adopted in 2018 itself, and there were already a deployments. So even if we get a new attribute, which is a transitive, but there is already an implementation and deployment, sure, we can take it in the with the authors. Thank you.
Thank you.
Satya, you have the queue. Satya, you have the cue. You'll need to hit your microphone button.
Sorry, sorry, Jeff. I was on mute. Can everybody hear me now?
We can hear you.
Yeah. So I will reply with respect to the second draft, which is the BGP DMZ, and that is because the extended community, the link bandwidth, right? As everyone knows, it's non-transitive, so cannot go across eBGP links. And yes, we do. It's kind of we are leveraging that ambiguity. We consider this as kind of re-originating, like you accumulate all the receive DXT comms, like the link bandwidth TXT comms, do the aggregation, and then send over the eBGP link. So that's why it's not in violation of any RFC, but that is why we have always posed it that way, and that's also widely deployed. And as to what people already said, yes, first one is definitely the base draft. So I think the second one is complementary to the first one, and we have always discussed that way. That is how we, at least in my mind, that is how we are going to progress it in the ITF. Thank you.
Jorge?
Yes, Jeff, thank you. Yeah, it's just a comment about the EVPN draft as a co-author. So the initial reason why we didn't use the link bandwidth extended community might be what you just said, that basically there was no transitive solution. But you know, in subsequent versions of the draft, the extended community definition actually evolved to address some other use cases, as Kiran and Krishna were also mentioning. And I also wanted to say, yeah, there are multiple implementations and deployed. So we don't really want to change this at this point. And finally, the fact that the extended community in this draft is EVPN type and subtype also has some consequences in other documents. I'm thinking about the EVPN to IPVPN to working draft that has a special treatment for the extended communities that are EVPN type and subtype. So yeah, that's my comment. I guess we need to discuss more.
Sure, Jorge, we can discuss this more on the forum. Yeah.
Okay, Wen, you have the cue.
Yeah, I have a similar comment. Just we probably need to sort it out in the BAS group because the EVPN draft, the reason for that is the transitive nature. We have EVPN extended community, but how are we going to sort it out? Ideally, it's good just to have a one BGP link bandwidth extended community. So next request BAS group to sort this out due to some implementation already there with the EVPN extended community. Now how we are going forward. Thanks.
Thanks, Wen. Xi?
Hi, just want to say that it's a useful update to include transitive property to this extended community. Actually, we think is a practical use case to make it transitive. And another point I want to raise is at least we saw some issues with the current floating point based format from some operators or from some customers. It is error prone in configuration, and when you use this bandwidth for some policy matching, this accuracy of the that may be some difference between the actual value and the value you express using the floating point format, so that it may cause some issue for some use cases. That is why the third one, at least here, the link bandwidth extended community extension is introduced. So maybe we can also discuss that kind of issues in the working group. Okay.
Thanks, Xi. Ketan?
Hi, sorry to hop back on the queue, and maybe this is a question for Hore when Krishna. If I wanted to use the new format, it's a non-floating bit, uh, floating byte format in the draft number 1 here for any other BGP SAFI. Would you be okay if we made it generic in BGP for other SAFIs, or did I hear Jorge say that there may be issues with doing that?
So we'll let them respond in time. I also have points to respond on there. Let's move to Jeffrey for the moment.
Okay, so one question I have is that with the proposed changes to the IDR drafts, do we still need the best eBGP DMZ draft? Is it has all the content been covered in the proposed updated IDR draft?
Conveniently, you're heading into the point that I was hoping to make. So Rishma, if you don't mind, I'm going to take over the screen.
Okay, thanks.
Okay, so I'm going to very quickly move between. Let's see here. Please give me a second to do screen sharing. Okay, so 2 points I wanted to hit briefly in terms of representation, and then in terms of scoping as a separate point. So here we have the unequal load balancing draft displayed. And one of the things you'll note here from the format, this is not necessarily using a floating point number. And this one actually has a value units. Offering as a related contrast, this is one that G has already mentioned. This is
Jeff, all we see is your face rather than the slides.
You're seeing my face. Well, it is misbehaving. That's weird. Let me go ahead and try again. I should not actually be sharing my face at all. Oh, sorry. You meant you're seeing my banner.
I'm seeing your banner.
Okay. Share screen. Accept screen. Allow. The object cannot be found here. Okay. Well, I apologize. I seem to be having screen sharing issues. I'm not going to take people through tech support. So just walking through the contents of the drafts. So the unequal load balancing draft, again, is encoded as a standard extended community, but instead of using the floating point value, it has chosen to partition the 6 bytes of data that it has to a value units field, and the remaining 5 is a value weight. Draft Lee that Xi had mentioned instead is a brand new attribute, that tries to work around the issues of the floating point number issues by having a 16 byte wide value. And it also has a scoping ASN in there as well. The reason to mention these things is that we have sort of 2 parallel problems, maybe 3, depending on how you frame it, that we're looking at for the set of questions that has just occurred. Problem number 1, we have basically a granularity and configurability problem. As I mentioned, Yang doesn't handle 32-bit floats very well. The Yang language actually uses decimal 64, which theoretically is a well-supported IEEE format, but language support in various compilers is a little weak at the moment. It just has the advantage that it is absolutely human readable, and that solves some of the policy issues that Xi and some of those other co-authors are sort of highlighting. Secondary set of issues that we're looking at is is one attribute suitable for every single use case? And I believe the answer to this is probably just no. The traditional link bandwidth that we have for internet scope things and for IPv4 and other similar families that are trying to do very simple load balancing across a single domain, I think it's probably working very fine on its own. We're seeing, for some of the EVPN use cases, being able to throw a non-transitive over the wall, addresses at least some of the gaps that might be there. But we're also seeing EVPN use cases where the bandwidth effectively is scoped to the application. We also have not presented today, draft shoe, which I encourage people to go take a look at, which does actually cover a very similar type of consideration through fabrics, where the single link bandwidth is probably not an appropriate thing. So we're looking at potentially need for more than one type of link bandwidth for applications. And this brings us to the third point, which is effectively scoping of these things. Today we only have two scoping values for extended communities. One is non-transitive within a single AS. We're highlighting as part of this work that potentially we will want to allow non-transitives to be thrown over the wall, so that a given domain can actually do its non-transitive work there. And we also have highlighted the fact that we have transitive, which has the issue that it may go much further than just simply the people who actually care about it. This is a flavor of attribute escape and is highlighted in the attribute escape document. So I'm not trying to highlight any specific solution to any of these things at the moment. Reshma and her co-authors have done a lovely job of helping us move forward our solutions for interop with existing things. What I'd like to suggest this is framework for these 3 additional points for the remaining problems, and seeing, we certainly have problems that are being solved right now in BESS, but we're probably looking at a broader problem that we should come up with a more general purpose solution that we can carry forward without having the link bandwidth of the day for each application as we come up with them. Do we have any other comments on link bandwidth? If not, what I'd like to suggest is that we return the remaining roughly 10 minutes of the call, maybe to go back to some of the chat considerations that we have, that was covering the multi-next hop and other forwarding properties. Okay, seeing nothing further in the queue for link bandwidth. The chat that we're seeing in the multi-next hop portion of our thread is about whether or not multi-next hop is sort of highlighting we do want to have all these properties in one place, but we're highlighting that some of the properties are forwarding specific and some of them are route selection impactful. Anybody want to take some of their comments from the chat and bring them microphone? Jeff, go ahead.
Yeah, I presume you wanted me to just repeat what you said on the chat. So, so there are a lot of BGP attributes that we have on a route, and some of them carry information that's related to forwarding, and some of them influence path selection, and this may be not a disjoint set. So the point I was trying to make was the things that go inside an MNH is only the properties which are related to forwarding, which may mostly get installed into the FIP. And that may also have things like cost, which are related to an endpoint in the forwarding, but it's just qualifying that endpoint or the forwarding towards that endpoint. So only those kind of properties, they get included in the MNH. And other attributes like local preference, for an example, which are purely like control plane path selection and other like communities filtering. So they are like purely control plane entities. They don't get into the MNH. They're not like forwarding properties. That's what I was trying to explain to G, and I may put some text in the draft describing this.
So I think a relevant discussion point, since we were trying to talk about things like a generic metric, I think it's fairly obvious that generic metric could be encoded in something like a multi-next hop, since it's impacting a next hop leg. We did also discuss continuity as one of your use cases, and that overlaps the generic metric portion of things. If the goal that you have, for you and the other authors on multi-nextop is to make this strictly impactful for forwarding behaviors, how are you seeing this interacting with various nextop components? So let's say that you have 3 nextop components inside your MNH. What if you need to have 3 nextop scoped metrics associated with them?
Yeah, so we do have those cases like so each of the next hop, let's say you have IGP cost to that next hop leg, which is not carried in the attribute, but it is like the IGP cost that we resolve. And then we also have the AIGP carried on a per list next hop leg. Now, each of the next hop legs will have those attributes of their own. And when we want to have a decision of what is my property X for the route, then it will be like the worst property of the primary legs. So it'll be, if you're taking the IGP cost, it'll be the worst IGP cost of the component member legs. So that is how you determine the effective IGP cost on the route level.
Okay, and G, I saw the the hand flash. Did you want to say something here?
Hi, Jeff. That was my question about the pass level and the per multi-nextop lag level attribute. If they both of them can impact the route selection, what will be the rule and what will be the impact to the existing path selection procedure? Maybe I didn't check the draft about this part, but it would be good to make this clear in the
Yeah,
document.
the draft actually has a section on impact to path selection, which describes this point. Maybe you can just go through that and I can clarify further if anything is not clear.
Okay, I will take a look. Thank you.
Thanks.
Okay, and I
And
think we've go ahead.
another thing, so when the MNH was introduced, it was optional transitive attribute, and that is when it had the advertising protocol next hop and checks based on the validity of the advertising protocol next hop cross compared with the next hop carried in the attribute 3 and 14. It was needed, but after that, based on the working group input, the MNH became a non-transitive. So right now we have the advertising protocol next hop still there, but there is a possibility we can remove it because it is non-transitive. And NHC has used the same mechanism of the advertising protocol next hop. And today John mentioned the caveat about the link local and those complexities. So after listening to all that, I'm thinking about whether we can just remove the advertising protocol next hop from the MNH because it is non-transitive and maybe it doesn't need that. So if the working group has any inputs on that, I would also, yes.
Right. It's very important to remember that the non-transitive just simply impacts how downstream implementations treat the attribute if they do or don't understand it. It doesn't provide information as to whether the route or the attribute itself has come from one or more than one hop away.
You're right. I mean, yeah, if all the nodes have been upgraded, then we need some kind of protection like this. That's right. Yeah.
I think you'll still want it for scoping purposes as well.
Cool. Yeah, thanks.
Okay, we have covered our agenda, and we have addressed, as best I can tell, all the points that have been raised in the chat. One final call for commentary. Otherwise, I think we can conclude this interim. Okay, seeing no hands being raised. Thank you everyone for your time. Please follow up with some of these things on the list. Clearly we've had some good discussion points that should be raised. We'll be trying to touch on the 4360 BIS points. And one of the things I'm going to suggest is a bit of work between BES and IDR for the upcoming IETF is discussing the more general point about how do we carry things like link bandwidth in a domain specific and scoped fashion that are applicable for our various use cases. Thank you, everyone. Have a good day.
Thank you. Bye.